don't consent.
You don't consent. I don't know if I can. I'm gonna have to cut that part out because otherwise I might get like flagged on YouTube.
Do consent.
um, client handlers .go. So we do the file name, then we do function name, post request privileges, and then this accepts an interface. So request, like I said, interface is any data type. So I could put just request and it will print it out properly. Yeah, I think that's good to go. So let me try and create this request. Tests. This is requesting admin privileges, so it's going to be. Oh, there doesn't have to be any election created. All we have to do is ping somebody that's running. So last time I just work in this file, test.go. I think that we're going to want to actually have a file that will continue to be generated because this is probably something we're going to continue testing. Probably want to do unit testing actually. That's probably the best way to do this. Which will be a little bit fun. Client handlers. What was this? So there is a convention with Golang on how to write unit tests. I am by no means an expert at this, but you have to create it's like the function. It has to be uppercase. It has to be the name of the function with test in front of it. You've got to pass this into it. So test post request admin privileges. So I've had trouble with this in the past with creating a post request in unit tests. I think I'm going to skip that for now because otherwise I'll just be figuring that out for the entire time we're doing this call. But I can create a request for now in this file. So there, test database dot the admin. We'll copy this request. All right, request database that requests admin privileges. We're gonna have to generate a public key and a private key. So crypto dot let me copy this from generate map data, because I know I do this here. Here we go. Private key, public key. Press admin privileges. And then, so we need the message, which we said was what was the message? Requesting administrator privileges. I don't like that this is uppercase. The rest is not. It's a little bit strange. Okay. We got the message. And crypto dot sign. Let's name the signature. Crypto dot sign. It's going to take in hash. So the message, it's going to take in the private key, and then the public key, or private key. Yeah, just private key, and then signature. No, it's going to return signature and error. So signature error. Message, and then private key. But then this right here is going to have to take in why does it say undefined? Oh, right. I gotta do definition. Then we'll do public key. What else does it want? Once. Probably the message, right? No message. It just takes public key, signature, something else too. What's the other thing? They're not equal to nil. And turn. Something else. Request.signature. And nope, that's everything. Message, public key, and signature. Huh. Right? Database. Node models. So I had message on here, but we said that we don't actually need this because the message is going to be the same all the time. It's never going to change. Maybe that's bad practice. It might be better to have the message in here. Although I think that we can pass it as the same. Okay, and then so I guess all we need to do is create a so this is the part where I'm not sure how to create a post request from Golang. So I think I'm just gonna, for now, for simplicity's sake, later on when I'm on my own time, I'll figure out how to send a post request with Golang, but I'll just format it with FMT. And this is fine because it's not actually in the files that make up Honestvote. It's in like a testing file. And I'll say, I'll copy this. So the format of this is how it looks actually. Did somebody say something? All right. So that's the way it's formatted. But this is actually, there's not going to be these brackets. These brackets are only for the router, Mux router, or Gorilla router. Plus concatenate this. All right. No, I don't have to create this. I don't know why I did that. This is pretty much it. So let me run this. I'll just print this so I can see the some more information because I actually need it. Change directory tests. Go run test.go. Must not have. What is test? That's confusing. Change directory tests. Go run test.go. And here we go. So I'll just copy this. Change the directory back to build, which I said earlier, that's the entry for the application where you specify all of the config information. I already have config information in the .env file, so I don't need to pass any flags. I can just go run main.go, and it will load up all these environmental variables, and I'll be good to go. That's the easiest way to run this application. So then I'll open a split screen terminal and it's running HTTP server on port 7003. So I'll go localhost 7003. You could do localhost. I don't know. Is the domain for 127.0.0.1 or the loopback address of the local machine. So Send this. Looks all right. 404 page not found. Signature equals public key. Something we did wrong. Girl local host 7003 elections. That's up. For some reason it did not recognize that URL. That's funny. Oh, you know what? It's because this is a post, not a I think I'm formatting this request wrong. No. How am I? Yeah, I think I am. Yes, I definitely am. Yeah, the request is formatted incorrectly. This should be the format that I'm doing. And that's why, yeah, I was wondering how it was going to decode this information. It's because I'm sending JSON object. So let's pull one of these in here. Should be a lot easier. Right, let's do curl header. Just make this easy for myself. Request, post data. So we're going to want to print this out to JSON. Again, I have a lot of this here. Same stuff. Like this is pretty much exactly what I want to do. File. Create. Request. Admin. Priv. Dot. txt. Or dot sh. Do that. So it's going to write this. Okay, it's going to take in a JSON object, it looks like. So we can do JSON request is JSON.Marshall. This is how I turn a struct, a Golang struct, into a byte array of JSON object. So we'll take in pointer to request and also take error. I don't think I'm even going to throw that error because it should just work, but I'll do it. If error not equal to nil, return. You should print out something, but for now I'm just going to leave them. JSON request. Okay. So that's going to be correct now. You understand the difference between the post and the get? So before I was sending just a get request, and a get request doesn't contain any data. You'll see. Let me pull this up. So a get request doesn't contain any data. It just has all of its information in the URL itself. So for example, here, this test, this is actually information. I can replace test with anything. And that's what a get request is sending. It's sending its data through the URL. But the post request is going to send the data through JSON. And so I was missing that information. But now I have it, and it should be good now. I don't even have to restart the server right here. I just have to regenerate the data. Go run test.go. And then should be able to run this. This byte array looks a little funny. We'll see. We'll see how this turns out. Yep, verify doesn't work. It has to do with that message because it's storing it as a byte array. And I think it's being a little bit goofy. That gets really complicated. So client handlers. Define message, request, public key, requested signature. I'm not sure if I need like some special encoding. I might need a special encoding in order to send that byte array to sign function. I don't know. I hope not. Private key, public key. Other than message should have no problem. I'm almost certain this is in verify. That's the problem, but I'm just going to double check, make 100% positive that this is where the error is being thrown. Huh. Oh shoot, this is wrong. This is the wrong URL. I don't really need these. I realize that now. All I need is this part, administrator request privileges. So I can just send it like this. I should update this in this file as well. Huh, looks like it went in. Let's see, and client handlers, where is it grabbing this? Didn't say anything, did it? HTTP routes. Administrator request privileges. I have 2 of these. See if that makes a difference. There, look at that. Post request privileges. Message. So it's printing it out. Now I can try it and comment these and see how it likes that. And I've got to recompile this every time I make a change to the code. And let's send the request again. Verify. It looks like it's verifying, right. Hash byte. What is returning? It's returning a result and error. So let's see, result, error. If result valid request. We'll name it valid request. If it is not a valid request, and if error is not equal to nil, and then we'll say, let's make this first. So like I said, this function does not take in a, this function takes in an interface, but it does not take an array of interfaces. So with fmt.println or something, you can keep adding different things or different data types, but this one you cannot. So I have to make this a string. So error.error turns error into a string, and then I can say here, I can say, actually, I'll just do an error for this one. This one I'll want to say custom message. I'm not sure if it will ever get here. I think that it might, just throw an error every single time that it's not a valid request. I don't know. So then here, for right now, just print this, see if it is a valid request. So we'll say valid signature, sending, nominating node.
Jacob, I think I sent you an email by accident.
An email? Oh
Yeah,
I did get an email.
My bad. Hold on, I gotta send it to the right one.
Valid signature, nominating node as an administrator. Right here, this is where we're going to implement the logic to send a request, like create an election and assign, like create registration transactions. That part is going to get somewhat complicated, but now we'll just test to make sure that this is definitely working. Valid signature, nominating full node as an administrator. Awesome. Matil, do you have any questions this far? Were you able to follow along a little bit?
Follow along.
Awesome. A lot of time it feels like I'm kind of talking to myself. I'm not used to doing this, so just let me know if it's ever hard to follow. So I said that I think that this will always be the same in client handlers. It will always be the same message, but I'd rather that it's able to send I think that I'd rather be able to send dynamically, because this is a very specific message. Although, if the message is too short, it might be possible for somebody to forge the signature. I'm not 100% certain that's true, but it might be true. And the reason why is because if this is too short of bytes, it might be possible to duplicate a signature with two different private keys. Not entirely positive, but like you could change the message until you're able to get a duplicate signature. I don't want to risk that possibility. For now, I'll just require that they give this message because it's somewhat longer, and I think it's enough bytes that it would be very difficult. I mean, it's enough bytes that it would be impossible to copy the signature. It would be impossible. If it's a specific message, it would be impossible, I think. Because only one private key should be able to generate that. Yeah, like I said, so this is probably susceptible to DDoS attacks until until there's some kind of form of payment required. somebody could just spam requests to become an administrator privilege and have these elections. There really shouldn't be any review process, or much of a review process before nominating a node. I can't think of what it would be. They are when they are nominated, the people that are selected. We can look in the story again. Jira. When the nodes are selected as like people, so somebody is nominated, a node is nominated, saying, "I'd like to become a producer node." 7 nodes are random nodes which using a predeterministic algorithm, meaning that there's agreement on which nodes are supposed to be registered, and that it's not the same 7 nodes that are always selected, or it can't be dictated by a single party. It should be random with and agreed upon by all nodes. Then those nodes, 7 nodes, will choose who is the next producer. And the reason we try to limit the amount of nodes that will be voting on who participates in who, like these are like the auditors essentially of that node. The reason that we pick them randomly and we only do 7 is because originally we thought about like where you just do majority vote every node in the system. But if you think about like if we had thousands of nodes in the system, thousands of people using Honestvote, it would get really burdensome to have to participate in these auditing a node every single time it joined the system, because like 1,000 nodes would have to vote every time every new node came onto the system. I'm getting feedback from someone. I think probably. I guess if you're muted, then it must be from AK.
Yeah, it's okay.
Process of elimination. Does that make sense? The reason why we have seven nodes. This is still a little bit up to debate. I'm just going to implement it, and then we can talk about theory later. But do you understand that, like, why?
Okay, 7, yeah, that makes sense.
You understand the predeterministic, like random generator.
Mm-hmm.
I don't know a predeterministic random generator off the top of my head, and I need to figure out how that's going to be implemented. But that's part of this story. It's necessary. All right, so this is going to be a fun part. We're actually going to send an election or create an election. Post election handler. We'll copy something that already exists. We will have to create an election. Their database dot election. So yeah, what we're going to do is we're going to create this election, like the election transaction, because the person that is getting this is an admin. That's getting this request is an admin. So yeah, it's going to be an admin. So they have the authority if they're already an admin, they have the authority to declare an election. They have the authority to create an election transaction that will be approved by the chain. So we can just create this, and then propose it. The way we'll propose it is we're going to enqueue this election transaction that we're going to create. So it's going to add it to the pool of transactions that are waiting, and then when it's this node's turn to produce a block, it's going to put that transaction among its other transactions into the block, and then it's going to propose it to the chain. And then we don't really have to worry about everything else that goes along with that, which includes like we don't have to worry about the TCP dialing the other node, and we don't have to worry about a lot of fancy stuff. Database.election. So I'm going to forget how this is actually formatted. So I'm going to have to go to node models. Again, node models is where we have like pretty much all of the structs that are defined. So election options, position, and candidate. Those are all the structs we need. Just going to copy this here so I can see them and then comment them out. PDP and Q nomination. All right, let's go. We don't need type. Election name is institution. Oh, so you see this stuff should actually be included in the post request. My buddy's calling me. Oh, it's at 11:51. We should probably close up and carry on the rest tomorrow. Are there any questions that you have about what we've done so far?
No, not yet. Pretty straightforward. Well, not straightforward, but like everything's making sense.
Yeah, it's like there's a lot of files and it's a little bit complicated, but like you just got to get used to our structure, I guess. And do you feel like your like the structure is logical, like, or do you like, I don't know, like you think you'll need like we don't have, our code isn't really documented. Like you'll see most of these functions don't have documentation above them. Is that?
I mean, I feel like it would be better in the long run to have documentation, but like most of the functions are straightforward, like in their names.
You're able to follow it. It's
it's pretty easily followed.
That's really good.
Even without the documentation, it's pretty easily followed.
That's really good. I'm glad to hear that, because we've been Matt and I have made like just about all the code, and but we've gotten very much in our heads, so we don't know much about like how it's whether or not it's structured well. It's for onboarding people. We want code to be organized really well so that people can be onboarded easily. That's the goal, and so that we can try to transition other people to take over the development team while we take on other roles. Yeah. All right. So yeah, I think we're gonna get this done for sure before the end of the sprint, before not this Saturday, but the following Saturday. and then we can start talking about the rain signatures. I can talk about them briefly today, and then go in more depth throughout the week because we just go until 12.
All right.
So have you heard of rain signatures before? You know?
Oh yeah,
familiar?
I read a couple of articles,
Okay.
and yeah, I looked into it a little bit.
Yeah. So there are a couple different kinds. There's linkable, traceable, and then there's just like completely anonymous. Um, Completely anonymous rain signatures are really only good for like uh, they're good for relaying information, but they're no good for blockchain in which you don't want double spends. So like for in our example for us, like we don't want people to be able to vote multiple times. So if it was completely anonymous, like right now it's not anonymous. So somebody sends a registration transaction and or with their public key, and so then when they vote, you're able to see that they've registered based on their public key. And then, but then based on their public key, the administrator that was in charge of issuing a registration transaction, you can see their their email address or whatever information is associated with them. I don't know if I've gone through the whole process of how it works. I have shown you a demonstration of it before, right?
Oh yeah, you show me the demonstration.
Yeah. So the if you just look in the mock data, the first thing you're doing is sending first an administrator, because only administrators are allowed to declare elections. They issue an election transaction. Then the registrant sends a registration request. So this is some voter, and that's going to include their public key. Once their email address and all their information is verified, like the only person that's getting this is the administrator of that election. Once all this information is verified, the administrator is going to issue a registration transaction that contains their public key. That way, when the voter sends so the voter on the front end application is going to see that the registration transaction for their public key has been issued to the blockchain. So then they're eligible to vote, and once they send their vote, they're sending it with their public key. So then the administrator, which has their email address and personal information related to that individual, then they can it's possible for them to trace a vote to registrant, which is not anonymous, which is a major. It's an extremely important part of the security of voting. So with rain signatures, we need to be able to check this relation between the registration and the vote, so that somebody cannot double vote and they can't vote if they're not registered. But then we also need to be able to be anonymous. And um, traceable rain signatures, I don't fully understand how they work, to be honest. But they are the best way, I think. Linkable rain signatures, I found a method where we could have a registration pool cutoff period, where like everybody registers until so the linkable rain signatures, you can check. You can't necessarily check who is the sender, but you can check to make sure that two transactions with like the same um, like a key. It's called a key, that they don't occur twice. In which case, if you had a pool of like a time, a certain amount of time, so like a registration window period, then everybody could could register at the same within that window, and then they would vote in a separate window, and they'd be sending every public key of every single registrant, and then also their signature. So you'd be able to somebody that's a validator would be able to check to make sure that no one had that somebody has a valid signature, one, and two, they did not send a signature twice. That's one method. But again, not a huge fan of that method. I think that there's a way that we can do it because I think it's slow and because I want people to be able to vote like right after they register. I prefer not to have a registration window. I think that you can do that with traceable range signatures. I don't fully understand how. And both linkable range signatures and traceable range signatures, we need an algorithm for it. Like, you're not going to find a Golang library for range signatures, and you're not going to find it for a specific use case of range signatures. It's hard enough to find like elliptical curve cryptography thing, or like. But range signatures, that's something so specific and so new that you're gonna have to create it. We're gonna have to create it ourselves, and that's why we've got Keith involved, and yeah, so it's a big task. All right, I guess I'll see you all tomorrow unless you have any more questions.
No, I'm gonna read more into it, but yeah, I'll see you guys tomorrow.
Mitchell, can you send me what you found on ring signatures?
Oh, like the article? Yeah, sure.
Yeah,
Very cool.
make sure you put it in Slack. There's a couple different you could put it in the development channel, or you could put it into yeah, just put it in the development channel.
So, okay.
Whatever, or yeah. There's a helpful resources channel as well that sometimes if I have a ton of articles that I'm posting, I'll just post them in that so I don't spam the development. But
Okay.
all right.
All right.
All right, I'll see you tomorrow. All right.
See you guys.
Or later tonight. See you.
Yeah.